Hi guys, so welcome to the party. Over here we have Winky dancing around to Punky's new Brew, which is our last installment of this project. So here's the way it's going to work. I'm going to quickly turn to KiCad, and then what I'm going to do is I'm going to talk about some of the changes that I've made. And then after that, I'm just going to show you guys a few examples of the sounds I was able to get with this module. At the end, I will show a sped up version of building process. If you don't intend to build it, then skip, right? But if you're going to build it, it'll be short. Okay, let's get going. So first thing, I made some changes. None of them were really, really huge, except for one was not huge, but it was a significant change. Originally, I had this inverted envelope following the envelope 1. And what I found was that I actually got better results when following envelope 2. So I made that change, and I obviously had to hack it. I'll show a picture somewhere. I don't know, somewhere over there. And yeah, so basically what it involved was basically since this resistor was connected to this end of the chip and this one here, but this is the same track, right? All of this is the same track. So all I did was just cut it from here, and then I just using a little wire, I just solder it directly to this end of this resistor, and that did the trick. So yeah, so you might if you won't have to do this, I will make sure that all the files are updated in GitHub. So if you do end up downloading the files after watching this video, all the things that I discovered and made changes on have already been updated on the files that you download. So these resistors right here were 100K. I changed this down to 1K, and I got a lot better results with the CV input. This potentiometer here was originally 500K. I found that having a 1 meg gave me a much better range. Lowering the value from 100 nanofarads to 47 nanofarads also gave me more interesting results. I changed these capacitors from 2.2 UF microfarads to 1 microfarad. I felt that the shorter decays just were a little bit more interesting to me. And then also I made the value of this release much, much smaller. I wanted an envelope that had more control over the shorter parts of the release. I did try different values for the LED to try and get it brighter, but because of the way this circuit is done, I really should have put this, with a transistor in there so it can get its own current without affecting anything else. It is what it is. Too low of value of this resistor will cause this LED to be brighter, and it will affect the response on your LDR. And too high, then it won't be bright enough, and you will not hear anything, right? And because of the way the curve, the response of this LDR is not really linear. Neither is the LED. So it's kind of a game, right? Finding this resistor value so that you try to get the flattest part of the response of the combination of those two components, right? I'm going to show you guys what this thing sounds like, and then I'll talk for just a little bit after that. All right, so there you have it. That's what this thing sounds like. Should you build it? You be the judge of that. If you do intend to build it, stay tuned after this bit here, and watch the building process. If you're not, feel free to skip. Don't forget to hit the like button and subscribe if you haven't already. And we'll catch you next time. All right. Now back to planning some more projects. Bye. Okay, so got the boards in the mail today. Let's go ahead and open it. Cool, freebies. Can always use more stickers. Wow. More freebies. Oh, these are useful. Nice. Okay, so here's what we got. That is the main board, control board. And then something else here, which I don't know what it is. Put this out of the way. Okay, yeah, so let's see here. I'm realizing that probably having the main boards be black probably wasn't the best idea, because if I have run into any trouble, it's going to be very difficult to see those tracks, especially since this is our first prototype manufacturer board. There's a high likelihood that it could have problems. So yeah, okay. Well, it's a relatively simple project today, so hopefully we won't run into issues. But if we do, we'll have to deal with it. Oh, these look great. So I want to show you guys something here. Can you see the light shining through right there? So yeah, here we have it. We have all the parts. Let's start putting this together. Okay, so here's the finished product with a gate in here. So this is the only thing that's normaled, which means that without this plugged in, it just behaves like an oscillator. When we plug this in, then we can trigger it with a gate. Yeah, and then we can also feed an external signal over here and use an external envelope on this one. This is the copy of this first envelope. All right.